Hey guys, William here with Shadowtronics. I just want to do a quick little video for a little how-to video if checking current in projects is a part of the process, and I just want to show you how you would hook that up to see the current draw of a project. As you know, my current home automation project uses a temperature humidity sensor and broadcast it wirelessly over 2.4 gigahertz transmission back to a controller. And I wanted to see what kind of current we're using. Our setup is a ATmega 328p processor using an analog LDR light dependent resistor and a SI 7021 IC squared temperature and humidity sensor. Then using a NRF 2401 plus transmitter, currently set on channel 50, which is about halfway in the 2.4 spectrum. Hopefully that'll focus. That's the little radio there. Yeah, focus. There it goes. Alright, so to check current, you have to put a current meter in line on the power. The easiest way I found to do that is to take one of these DuPont cables here and cut it in half. Put your negative lead on your input side of your project, which here I'm supplying 3.3 volt, actually from a version 1 Uno board with the chip removed, just using it as basically a power supply right now, and a USB to serial. More on that later. And then you take your positive lead and tie it to your source voltage. Most meters are the same. I'm using just a cheap Syntec Chinese multimeter from Harbor Freight. They work, they're cheap, they're not, if you're doing home DIY stuff, they're great. If you're doing mass production, high quality products, you probably want to use a better meter. But like I said, I'm just a good old country boy, doing stuff at home, keeping the hobby alive. So, hey, it's cheap. Okay, you want to set it on the amps function. There are two. There is one for AC voltage and one for DC voltage. And if we look here on my meter, my milliamps range, which is what all this will be a milliamps, unless you're running something like high-powered LEDs or something that's going to draw more than an amp, and then you're going to need a bigger power supply. And we see here, it says that the milliamp is rated at 200 milliamps max, and then I have an unfused 20 amp max for doing AC or high voltage DC. So we're going to set that on the milliamp range, and we've set it to 20 milliamp because I know my project here doesn't draw that much. Okay, I've got everything wired up, and I'm doing this just a little bit different just because it's easier on me to plug my cable in. Of course, black is your it's common, but it's actually not uncommon because you're putting it in circuit in thing. So for power, to smooth the power a little bit and give it some reserve, I have a 100 UF capacitor on the power rail, and also on the radio here. If you can see, I have a small 10 UF on the power rail of it to help with power spikes, and we'll see that here in just a second. We'll go over here, get that to focus, get my drink out of the way here. Like I said, this is set up to 20 milliamp. So we're going to plug it in and we'll see it boot up. I'll cut in the video, hopefully, if I can figure out how to do it, from the screen of the console window there booting up. So as soon as I plug this in, the chip will power up and the radio and all, and you'll see the capacitor charge, and you'll see the first transmit. So here we go. We're going to plug that in. You can see it starts at about 4 milliamps, 4.25. Then there's when the transistor comes on to turn on the radio. So I'm assuming that's the first transmit and the capacitor on the radio charging. And as you see, after the first transmit, there, we're setting at 3.23 volts at 4.25 amps, milliamps, sorry. We'll wait 1 minute here, and you'll see it transmit again. See if I can get them both in the shot here. Oh yeah, that actually is working pretty good. We'll let it transmit one more time. And you'll see this time as it transmits, the amps don't spike up like they did before. That's because the two capacitors put a reserve on the rail that it can pull from it instead of pulling from the source voltage. Actually, I can show the difference. I can pull the cap out and we'll see what the difference is there. Okay, it's taking the readings now and transmitting. And if you've seen that, there was no spike. So this time I'm going to pull the 100 UF cap, and let's see how the current reacts to not having that capacitor. As you can see, I just removed it. Be careful. I have to be careful here because it is charged. I don't know how much of a bite you would get off 100 UF. I don't want to find out. If everybody knows me, knows that me and electricity just don't get along. So we'll set that down there over there easily. And if you notice, our current draw has actually dropped some down to 4 milliamp. Actually, it's continued to drop there. Okay, so what we're going to do, we're going to pull the power. As you can see, it went to 0. We'll give that 10 UF capacitor a second to discharge on the radio. Okay, that should be good. Alright, and we'll plug back up and watch it boot. Okay, we're at 4 milliamp. Oh yeah, you can see it stayed up there a lot longer at 18 milliamp. During the building of the package and transmission of it. So we'll wait another, so our voltage is still the same, 3.23. And so we'll wait a second here and let it transmit again and see how much of a difference that 100 UF is actually making as far as current being pulled from the source. Again, it's always good to put some smoothing capacitor, at least one smoothing capacitor in a project, because DC noise can be noisy from especially if you're running off USB from a laptop or a desktop computer. There's a lot of noise on the USB lines. I have the year. Okay, here we go. It's taking the readings. Okay, it didn't jump up there too bad. So that actually didn't really move at all. So that 10 UF on the radio really does help. All right, that's about it for this video. If you have any questions, comments, leave them below. In the description below, I'll list all the hardware we're using, and I'll do some still shots of my setup here. And that's about it. And I can put my 100 UF capacitor back. Make sure I put it is polarized. For you people might not know, these are electrolytic capacitors. They are polarized. One side has a white stripe. We'll try to get this to focus here. I don't think it's going to focus for me. There we go. The white stripe means ground. And as you can see here, this cap is rated for 100 UF at 50 volts. So that's about it. Just a quick little short video on how to check the current of a project. Alright, if you have, like seeing question, comments, hit that hit the like button, dislike, leave a comment, hit subscribe, and visit us at shattertronics.org for more information. Thanks and have a blessed day.